எனக்கு வாய்ஸ் கேக்குதா இல்லையா எனக்கு தெரியாது. Good morning, everyone, and wishing you all a happy 75th Independence Day. On this occasion, our BCTLABS proud to present a workshop on circuit designing using Tinkercad. We BCTLABS provide STEM education since 2013 to various schools and colleges. We engage students in various STEM-related activities like competition, paper presentation, project presentation, and the conference like so many international conferences. We also got the best paper award in international conference. So today we are going to learn how to design a circuit virtually without a hardware components using Tinkercad software. So without further delay, let's start the workshop. Okay, enable me to share the okay. Okay. Yeah. So fine. So today we are going to design a circuits, I already told you, using a Tinkercad software. Okay. So this workshop is for a school and college students, as I told before. So agenda of the day. So introduction to Tinkercad, basic operations. So here we are going to do 3 projects in our workshop today. So first project which we are going to make is automatic light on and off system. The second project which we are going to make is basic LED connection with Arduino. And third project which we are going to make is smart home automation using Arduino Uno. So first, let me start into that. What is introduction of Tinkercad? Okay, so first let me tell you what is Tinkercad. So Tinkercad is a free web-based 3D modeling and printing application that can help you to design and printing of 3D objects. Not only this, we can design an electronic circuit also. Okay, so what are the things you have been designing using this Tinkercad? It will be stored in your account, so you can access that at any time. Okay, you just have to go to the Tinkercad dashboard to get the works of yours. Okay, so basic thing which we require to use this Tinkercad is your laptop and your internet connection. This is enough. I request all the participants to not overwrite anything on a screen. Please do so. Okay, our first project, automatic light on off system. Okay, so for making this, the name itself implies that. So automatic, what it means, what it going to on and off automatically. Okay, so without the human help, it's going to, we are going to on the lights whenever we require. Okay, so for making this project with our empty hands, we can't able to do anything. Okay, so we required some of the electronic materials to do the project. So first thing we require is LED bulb. Okay, then we are going to use a motion sensor and the 5-volt battery and the wires. Okay, so LED is nothing but light emitting diode. Okay, using this we are going to flash a light. it has two terminals. One is anode and the one is cathode. The long leg is anode. The anode is nothing but positive. The short leg is cathode, that is negative. Okay, and then motion sensor. So I told you that we are going to do automatic lights on and off system. So what is nothing but we are going to sense the motion of an object or a person. Okay, once the object is detected, then we are going to turn on the LED. Okay, if nothing was detected, the LED going to be off state. To detect the motion, we are going to use the motion sensor. You might have the doubt, what is sensor? So we humans, we interact with the physical world using our sensory organs like eyes, nose, skin and tongue, right? Like that, the system or something has to physically interact with the world using a device. That device is said to be a sensor. The sensor is a device which can sense the environment, okay, physical environment. That's what here we are going to use a motion sensor. What it will do is it going to sense the IRAs which is emitted by an object. Okay, it has three pins. One is positive and the one is negative, then one is signal pin. Three pins will be there in motion sensor. Then here, so as we know, to power up an electronic device, we require a supply. So how we are going to get the supply to is nothing but we are going to use a battery. Okay, here we are going to use a 5-volt battery. Why? Because the operating voltage of LED and the motion sensor was 5 volt. So we require a 5-volt battery here. Then to interconnect each and every components with each other, we require a connecting wires. So we are going to use a jumper wires here. So do we all have these components with you? No, right? So here in this workshop, we didn't require any materials. Without a material, we are going to do in a website. Okay, so everything is going to be virtually made. So let's start a project one. So let me discuss about the connections of this one. So I told you that the materials which required was motion sensor, battery, and the LED. So as we know, we have to power up the device, right? So powering up the device, we have to connect the positive and the negative to the battery. So here, what it is, there was the power is connected to positive of a battery and negative is connected to the negative of the battery. Okay, then the signal pin, the last first pin will be a signal pin. So what it means, what when the signal is high, okay, when the motion is detected, then the signal going to be high. That should makes the LED to on. Okay, so LED will be connected to the signal pin and the negative should connect to the ground of the battery. So now we are going to design it virtually. Let me start. Yeah, this is what your Tinkercad dashboard will looks like. Okay, you have to log in with your Gmail or you can log in with your class code. So first I'm going to circuits. Okay, so this in your dashboard you have to choose circuits. Once you choose a circuit, you can see a thing called create a new circuit. Click this create a new circuit. Okay. So I told you that we are not going to have any materials with us, right? So in a Tinkercad software, it have all the components in this. So we can drag and drop and we can interface the components and we can stimulate it to find the output. Dear participant, I request you to not overwrite on the screen. Please don't do that. Okay. So first component I have told you that a LED. So I'm taking LED from here. Then I'm going to use a battery. So I'm taking a battery. Then I'm going to use motion sensor, that is PIR sensor. Dear participant, please don't overwrite on the screen, please. Okay, so let me start correcting each of those. Okay, so fine. I'm connecting the components, right? So first, see, I told you that we are going to use a 5-volt battery, but here you can find that 1.5-volt battery, but it is not sufficient to turn on a device with that. So once you click over the battery, you can find a menu like this. Okay, so in this menu, you have to add a batteries. So if you had one battery, it will be dear participant, don't do anything like this. Just a minute. Okay, so while you're clicking over the battery, you can find the batteries like this. Okay, if you had one more battery with 1.5, it will be 3 volt. Okay, if I had one more with that, it will be 3 volt plus 1.5. It means 4.5. If I'm trying to add 4 batteries, that is 1.5 plus 1.5 plus 1.5 plus 1.5, it will be 6 volt. Okay, if you use a more power, then your components will get damaged easily. So what you're going to do is click a 3 battery, so it will be near to a 5-volt battery. So I'm going to use this. So as I told you, I'm going to connect a power to a positive of this. Okay, for my convenience or for my understanding, I'm going to use the wire color. Okay, so here you can find a wire color. Click this and change the wire color as red. Okay, so positive means red, negative means black. So for my understanding, I have changed this. Then I'm going to connect the ground. Okay, so I'm going to take the wire from ground. See, I'm not taking anything, just clicking over the pins and just dragging here. Okay, then I'm connecting to negative. I told you before that for my understanding, I'm going to change the color of it. So my for black, it will be black color. Okay, so power should be connected to the positive of the battery and ground should be connected to the negative of the battery. Okay, and LED has 2 terminals, already told you. So this is an cathode is negative, anode is positive. Okay, so when the signal is high, then the output will be 5 volt. Okay, when it got 5 volt, then only the LED has to on. If it doesn't require that one, it will be off. So I'm going to connect a signal pin to the anode of the LED. So for my convenience, I'm changing this as orange color wire. Then I'm going to connect a cathode to a negative terminal of the battery. So for my understanding, I'm taking as black. Okay, so I hope that the connection will be clear to you, right? So positive I have connected to positive of the battery, negative I have connected to the negative of the battery. The LED is same way. The LED negative is connected to the battery and positive I have connected to the signal of the PIR sensor. Okay, so PIR is nothing but a motion sensor. It's going to detect the motion of an object. So without further delay, let me start stimulating this. So I'm going to click start stimulation button here. So once I have clicked, I have to click over a PIR sensor. Then you can find a ball-like structure. So consider this as an object or a human who is going to move. Okay. So while I'm moving, it has to on. If it is in idle place, it should off. Okay. So while moving, the object is moving means the light has to on. If nothing was happening means the light has to off. That is what automatic light and on off system. Okay, when the object or a person is there in the room, then the light has to on. If nobody was there, the light has to be off. Okay, so I'm going to stimulate once again. So see this. So it's an object. When the object is moving, the light will be on. If object is in stable place or idle, it will be, the LED will be off. Okay, this is what your first project. So you can do it using your Tinkercad software by your own itself. Okay, without requiring any hardware components with you, you can able to do this. Okay. Now, so we have completed our first project for the day, and next, where we can apply this project. Any idea you have? Can you please comment it on the chat box? So where we can implement this projects, like automatically on and offing the system. If you have an idea, you can comment it. Yeah, very good, Swati. Now home, office, then in cars, super. Street lights, very good. Industries, in malls, streets, in hospitals, very good. Good ideas. Everywhere where we can want to apply this one. Very good. Yeah. Good. So some of the areas I have posted here. The first one is nothing but a washrooms in our home. We might have a fear of going to washrooms in the night times, right? So if you implement this project, what will happen when you're entering into the room itself? It's going to on the lights. And then storeroom of your home or else in your schools and everywhere we can use it. And as you said, the malls. In malls door, we have an PIR sensor. When you're going near to it, it automatically open the doors. Then, by implementing this project, what will be the benefit of this? That's one of the biggest questions. So what will be the benefits? What will be the benefit of this? Yes, what will be the benefits? If I implement this is what my thing. Okay, it's automatic. Energy saving. Yeah, energy consuming. Very good, very. It's actually an energy saving. So what kind of energy we are going to store or save? Can you guess? What kind of energy? Yeah, saving energy, that is saving electricity. Definitely. By implementing this project, we can save electric energy. So that we can save our money also. So while saving electricity, we can save our money. Very good. So next, moving on to our second project, that is basic LED connection with Arduino Uno. Okay. So first, let me understand what is Arduino and how to connect the LED and how to make it to be do automatically. Okay. So first, so materials required for doing this project is LED lights, wires, and Arduino Uno board. First, we understand about what is Arduino Uno. So what is Arduino? So Arduino is nothing but a microcontroller. Okay. So microcontroller is nothing but a chip in a computer. It's going to control all the inputs and outputs of the thing. Okay. So it's an open source platform. So anyone can use it. So it will be easy for you to go with. Yeah, good. It's chip. This is what Arduino Uno looks like. You can see this in my hand. This is what an Arduino board. Arduino board. We have a USB plug to power up this and to upload a program. And then we have a digital and analog pins. Okay, so digital and analog IO pins will be provided so that we can interface with the input and output components. So this it has 14 digital pins, that is from 0 to 13, and A0 to A5 will be an analog pins. It has 14 digital pins and 6 analog pins will be there. Okay, it is a model of Atmega 328 microcontroller. So microcontroller is nothing but a device like our brain. Okay, we can take an example as our brain. Our brain is controlling all the activities of us, like that the microcontroller is going to control all the activities of the inputs and outputs. It has an inbuilt voltage regulator. Why? Because we are going to connect up components for Arduino with a 5 volt supply. So if getting the more supply, it's going to regulate the voltage from 12 or 9 to 5 volt. Then we have a reset pin so that we can reset all the programs which we want. Okay, then so this is what a connection. Okay, we have a Arduino board and we are going to use the breadboard, then LED and the resistor. Okay, so LED we already know. I told you that LED is a light emitting diode. We are going to make it to on and off. That's what we are going to use. It has two pins. One is long tail will be in positive, that is anode. The short tail will be in negative, that is cathode. Okay, and we have a resistor. Resistor is a device which can resist some amount of current. Okay, the flow of current will be reduced using the resistor. Then we are going to use a breadboard. So breadboard is nothing but you can use a breadboard to make a simple connections. It will be user friendly for us to do. And then we have a Arduino Uno board. So Arduino Uno board is an open source platform so that we can use this. Okay, so without further delay, let me complete this one. The project. Okay, so now we are going to make connections in the Tinkercad for this Arduino. So I'm going to delete all the things here. These. Battery. Okay, so the components which we are going to use is Arduino board. So just see, I'm dragging and dropping here. That's it. I'm going to click the component here and going to drag and drop. Breadboard, mini breadboard I'm going to use. Then LED. And resistor. Okay, so I'm going to place it here. In breadboard, it has a parallel and serial connection. So here in this mini breadboard, we can find a parallel connection alone. Okay, so I'm going to fix it here. Once you're connected up supply, it will be flow in a vertical manner. Okay, so this all the strips in the same line will get a power. So I'm using this one. Then I'm going to connect a resistance here in a negative end of the LED, that is cathode. I'm connecting here, and then to ground this, I'm going to take a ground from Arduino board. Just going to click this, dragging this towards the LED second end. That is where we are connected the system. Negative end we are connected. For positive, I'm going to connect this in a digital pins. I told you that it has 0 to 13. That is 14 digital pins it has. I'm going to use a second pin here. So click here and then just simply drag and drop the thing and change the red. So I have changed this red because of my convenience, my understanding. I have changed this. So first, okay. So is that better to start a simulation? It will do? No, definitely it won't do. Why? Because the control requires some command from us. So what to do and what to don't do. Okay. For that, we are going to use a coding. Coding is a language which using that we can communicate with the system. So here in Tinkercad, it has three things will be there. One is block coding, a block with text coding, or a text coding. So I'm going to teach you a text coding so that you better understanding for you. Okay, so then, okay, it has two functions. Actually, the Arduino software has two functions. One is void setup and the one is void loop. So in void setup, whatever the comments which you're giving, that will be executed for only one time. If you are giving in some of the commands in a void loop, it will be executed continuously. Okay, so now I have used a LED. So I'm going to define the LED, that is integer. I'm going to use integer. Why? Because integer means 1, 2, 3 like that. So LED is going to turn on and off only. I'm not going to do anything. Somebody is accessing the thing. Okay, so I'm adding the variable to store the value which I'm going to give as an input. So I'm going to define that LED in an integer, that is 1, 2, 3, like that. I think there is this one. Ma, don't overwrite in the screen, please don't do that. You're overwriting this. Okay, don't overwrite anything here. I've selected this one, so fine. Now, so we are going to do the coding. First, I'm going to store the variable. Okay, in that I'm going to define it like LED equal to, I've connected LED in second pin, so I'm defining this as LED integer, and then I'm giving a semicolon. If you didn't give a semicolon, then it means that it is not, a command should not be end. It will wait for the ending to the next thing. Then pin mode. So pin mode, here you're defining which pin is this. Actually, we are defining pin mode of 2, that is LED. LED is an output component. It's not an input component. Be clear in that it's an output component. Okay, so LED is an output component which we are using. In while loop, we are going to make the LED to on and off simultaneously. For that, okay, we are going to use a function called digital write. It means that we are going to write digitally that to on or off. Okay, so here I'm going to on or off the LED digitally, that is 1 or 0. Okay, digital will be 1 or 0. In analog, it will varies continuously vary, that is 0, 1, 2, 3, like that. I'm going to use a digital write here. I'm going to open the bracket, that 2 or LED, comma, high. High should be in a caps. Then I'm going to give a delay of 1000. It is considered as in microseconds, so I'm giving 1000 microseconds. The same way, I'm going to write for of the LED. So in this digital write, LED, comma, 0. Delay. Okay, fine. We have written the delay of 1000. It's going to on and off for 1 second. That's what we have defined here. So let me check whether the given program is correct or not. Okay, so for that we are using a debugging thing, that is that simulation. So once you start simulating the code, it will debug that first. Debug means it will check the errors. Okay, it's on in and off, on, off, on, off, on. It will on for 1 second and it will off for 1 second. It will on for 1 second, it will off for 1 second. Yes, is this working? Yeah. So the same way we are going to connect 2 more LEDs to check that to work in a simultaneous manner. I'm going to remove this one. For this, I'm going to use mini breadboard, mini, very small breadboard I took. We can undo this for the things we not require by clicking here. Undo or delete. Then I'm going to take 3 more LEDs, LED 1, LED 2, LED 3. Okay, then we are going to use a resistor to resist some amount of current. That resistor 1, resistor 2, and resistor 3. Okay, then resistor 1 should connect to the 2, this digital pin, and resistor 2 I'm going to connect it in a 3rd pin. Resistor 4 I'm going to connect in a 5th. Okay. Then I'm going to take a common ground from here. I'm going to give in the breadboard. Okay. Then here we can take a common anode, that is cathode, and connect to the all the ends of the resistor. Okay. So now we have connected all the 3 LEDs with the digital pins and all the ends of the resistors to the ground. Okay, it is common ground. Here you can find a vertical and horizontal ways in a breadboard. So if it is vertical, it current will flow in vertical way. Okay, this is parallel connection. Here it will be called as in serial connection. Okay, it will flow, current will flow in this direction. Here it will flow in this direction. That's what difference in it. Dear students, don't do anything on the screen, please. Okay, then. So after connecting everything, we have to go with the coding, right? So first one, we have made the coding as. So first, for only one LED, we made only one function, that is int of LED is equal to 2. For 3 LEDs, we have to define all the 3 LEDs. That is, first one is second pin is connected to second pin, and second one is LED 2. So I have to define a exact name. Okay, then only it will accept that. If you give the same name, the thing will not accept it. So you should be clear about it. So I'm giving for LED 1, it will be LED. For LED 2, I'm giving the name as LED 2. LED 2 is connected to 3rd pin. Int LED 3 is connected to 4th pin. Okay, and I have to define all these things. Okay, I have to initialize this. Initialize means once it has to execute. That I have to define the pin mode. Pin mode, pin should be small and M will be caps. These are all predefined function. We can't able to change it. So you should give in the same manner. If you give differently, it will not accept it. Okay, I'll show the demo for that. So I'm giving this as a mode. Okay, so let me check that. 3, comma, all the LEDs will be in output. So I'm writing this as an output. Then pin mode. 4, comma, output. Okay, The same way, you have to write it to digital on and off the LEDs. First LED we have made that. For second LED, digital, right? LED 2, high, delay 1000. Same way, I'm going to off the LED. For offing a LED, digital, right, LED 2, low. So delay of 1000. So if we check this by clicking this. So here I told you that pin mode. Here it shows a error. Okay, in function void setup, error pin mode was not declared in the scope. Okay, so what I'm going to do is I'm going to check here. I told you that pin mode, it's a predefined function. We can't able to change it. M should be in caps. Okay, then let me check this. I start stimulating the command. Now it started. First it will on, next it will off, then second it will get on, and first it will on, second it will be off. Okay, same way we have to do it for third LED also. The same command, that is digital, right, LED 3, high, delay 1000, that is for 1 second. Then the same way after off that, to digital, right, LED 3, low. Okay, then delay of 1000. I'm going to debug the code by taking start stimulation. You can find that first LED will off, on and off, then second will on and off, and then third will on and off. It will repeat continuously. Why? Because have give this thing in a while loop function. So while in while loop function, it will do it continuously. If you give this commands in a while setup function, it will execute for only one time. Okay. So first LED will on and off, then you will go on to second LED and it will on and off the second LED. And the same way, all the 3 LEDs will on and off. So we have understand about the basic concept of how to code Arduino board, right? So let me move on with the third project. Okay, the project 3, that is smart home automation using Arduino. Okay, so first basically we understand how to code to on and off the LED, right? So like how to give the digital commands like digital write, digital read, like that. So here we are going to understand how to interface the Arduino within input devices, that is sensors. So here we are going to use some of the components, that is LED bulbs, wires, and PIR sensor. The same for as we used in the first project. Okay, this is what a circuit. Here I'm going to connect the PIR sensor with Arduino board and the LED. When the PIR sensor detects the motion, then the LED has to on. If it didn't detect any motions, it has to off. Okay, the same way we are going to do, but the thing was it is going to do automatically with the commands which we are going to give. Okay, we can use a servo motor or a bulb like that to on and off. I'm going to Tinkercad to work with this. Sharing this. Okay, I have to remove all the connections. or else you can go to Tinkercad again. You can create a new circuit here. Yeah, we can change the color of the LEDs. I'll tell you how to change the color of the LEDs. There is no humans. We are going to use a software like this. So it will object like a ball will be there. We have to consider that as an object or a human. Then we can move on with this. I'm going to use Arduino. So if you choose second Arduino, you can delete it by clicking a delete here. Okay, then I'm going to use PIR sensor. I have to drag and drop this. Then breadboard. I'm going to choose a mini breadboard here. Then LED. Resistor. If you want to change the color of the LED, you should click over the LED and you can find the color. Okay, in that you should choose which color the LED has to glow. So now I'm going to choose orange LED. So I change this to orange. I'm going to keep the resistor, connect to the cathode of the LED, and the positive has to go to the signal pin of the Arduino. So here I'm going to connect the signal pin. Second pin. So for my understanding, I'm changing this color as blue. Okay, and this should be connected to the ground of the Arduino. So for my convenience, I'm changing this color as black. Then the signal should be, I told you already, the signal should go to the when the signal is received, then only the LED has to on, right? So I have to connect the positive pin to the LED. The signal should be connected to the positive of the LED. So for my understanding, I'm changing this color as orange. Then this is power. To power up this, I'm going to connect it to the wheel of the Arduino board. Okay. So it should be a red color. Then I'm going to connect the ground to the ground of the, this I consider this as a common ground. Make it as a black. Now let me see how to check the or how to read the values from the sensor in a Tinkercad. Okay, so first I'm going to change this as text. Continue. Here we have to define what are the components we have added. So now I'm going to add a variable that is int PIR sensor equal to 0. That is, I'm storing the PIR sensor value should be 0. Okay, the variable which I had was PIR sensor. I've added as an integer value that is 1, 2, 3. Like it's going to add pin mode. In mode, I have to define that what are the things I have connected. So one is but the second thing I have connected. First it has to be connected here and then it has to be connected here. Signal pin I have to connect to the signal pin should be connected to the second pin of the Arduino. So the color has to be changed as red, and then anode of the LED is connected to the third pin of the Arduino. The signal will go to Arduino, then the command will be sent to the LED, that is to on or off. The coding here. LED, that is second pin is that is input, PUT. All the sensors are considered as an input, all the actuators are considered as an output. Actuators is nothing but motors, displays, LEDs like that. So then pin mode, 3, output. That is LED is an output device, so I'm using as an output. Then I have to write the code for this. First, I'm going to write a code PIR sensor. That is a variable which I have defined in the top of it. Sensor is equal to digital read. Here I'm going to get the value from a sensor, that is digital values. I'm going to get, that is 0, 1, 2, 3 like that. I'm going to get, so I'm using this digital, that is 0 or 5. Digital value is nothing but 0 or 5. Why? Because the Arduino output will be 5. So if it is not giving the output, the value will be 0, that is low. If giving the output, the value will be 5, that is high. Okay, digital read. R should be in caps. Digital read of 2. Once you read the value from digital sensor, then you have to check that what the value, when it is high, it has to on. So I'm going to use if statement. If statement is a conditional statement. Here we are going to check the condition of it, whether it is detecting the motion or not. If it detects the motion, then the value will be high. So you have to turn on the LED. That is, PIR sensor is equal to high. That is, it detects the object. Then we are going to on the LED. If it is not, we are going to off the LED. So that PIR sensor value, if condition I'm going to use, if PIR sensor is equal to. Okay, it's not ascending operator. So PIR sensor is equal to high. We should not give a semicolon to the if statement. If you give so, it will error. It will make an error. So open the bracket and write digital write LED, comma, or 3, comma, high. Delay of 1000. The same way, if it didn't detect anything, the LED has to off. Okay, so I'm leaving this as it is. If it is high, it's going to detect. If it is not, it's not going to detect anything, or it's not going to do anything. So I have to check the program or coding whether it is correct or not. Okay, so it's running now. Let me check the output of it. Click over the PIR sensor, as I said before, and check out whether the LED is detecting or not. So once the object is detected, the LED has to glow, right? If it is not so, the LED has to be off. If it is detecting, the LED has to on. If not, the LED has to off. This was the concept of making the home automation. Okay, when the person is entering to the home, then LED has to glow. If so, but nobody was there, the LED has to off. That is what a condition. Okay, using PIR sensor, we can detect the motion. Once again, I will tell you the coding. First, int PIR sensor is equal to 0. That is in variable PIR sensor. I'm going to store a value as 0. Then it's going to execute for one time. That is pin mode. Initializing first time. That is second pin is input. That is from our PIR sensor. Third pin is output. Then while loop. It's going to do it continuously. If PIR sensor is equal to high, the value which is read from the pin 2 is high, then we are going to digitally write the LED to on. If it is not, then it should be off. That's what I command. Okay, so this is what our third project which we have done. You can work with the Tinkercad software. Okay, so where we can implement this project? You can post your ideas in your chat box where we can apply this project. Yes, school, home, house, bank, home. Yeah, good. Schools, office, malls, bank, hotels, schools. Yeah, great, great, great. So we are going to implement this project in the schools, malls, and everywhere for making the lights to on and off automatically. If somebody was not there, it's going to be off. If somebody is there, it's going to off. Even we can implement this project in a street lights also. If nobody was there, there is we can reduce the power, right? So we can off the light and we can use it for some other purposes. Restaurants, industry, supermarket, vehicle parking. Yeah. So what is the benefit of this project? If we implement this project, what will the benefit which we get? You can post your ideas in your chat box. Energy saving, okay. Energy saving, power saving, yes, yeah, great. Not only that, we can save a human effort also. By using this, we can reduce the human effort. There is no need to on and off on and off by manually. It will be helpful for them to off and off on and off it by automatically. So we can implement this. So it's a time for us to post your feedback form. Once you posted your feedback form, you're supposed to fill it. Okay. One of filling the post feedback form will get the certificates after the end of the session. Please fill your feedback forms right now. Thank you. Okay. You will get a mail from us with the feedback form. Kindly complete that. Thank you.